So today we're gonna discuss the sides and angles of triangles and also something called the triangle inequality theorem. So make sure you're titling your notes. Okay, so which side is the longest in the triangle below? And how do you know? So let's look at this together. We have a triangle with a 120-degree angle, a 45-degree angle, and a 15-degree angle. Okay, so which side would be the longest? So I know we've been saying you can't trust your eyes, but if we're looking at this, we have this this obtuse angle right here, and then we have this very long piece there, okay? So if I pull that to the side, that is the side opposite the 120-degree angle, okay? And now this diagram is not drawn to scale, obviously, but if we're looking at this, this side is the longest side. Because even if I drew this side and this side, and I brought them over here, oops, them separate. If I drew this side, notice how the blue side's still longer, and then this side, notice how the blue side is still longer, okay? So the angle or the side that's biggest is always going to be opposite the bigger angle. So notice how we have the 120-degree angle, so the side opposite would be its longest side. How about this one? How do we know what the largest angle is in the triangle? Okay, so the largest angle we can see here, this is an obtuse angle. Clearly it looks obtuse. And notice how it's opposite of this side that's 15, which is the longest side. So this angle, the angle opposite the longest side, is the largest angle in the triangle. Okay. So if that can help us find the longest side and the larger angle, we can also say that about the smaller side and the smaller angle. So two things. The largest angle is always going to be across, or we can say opposite, from the longer side. And the smallest angle is always going to be across or opposite, we can say, from the shorter side. So make sure you write this down. You can pause the video to make sure you have it all written in your notes. Okay, so let's look at this diagram. So note that this is not drawn to scale. Okay, none of these are drawn to scale, but if I want to name the largest angle, I have to find which side? The biggest side, the longer side. So that I know that the biggest angle here is angle I. And the smallest angle is going to be across from the shorter side. So I have 6 as the shorter side. So I know that this angle here, angle H, will be the smallest angle. So if we know that, we can make some generalizations about the sides and about the angles and how large the angles are and how long the sides are. How about for this one? So we have 105 degrees and then 46 degrees. So I want you to find the longest side and then the shortest side. So we don't know what angle T is, so we have to find it. Okay, so 105 plus 46, and then we have to find that third angle. I got was 29 degrees. Again, remember you can use your calculator for arithmetic. I'm okay with that. So the biggest angle is this 105-degree angle. So I know that the longest side is side length TX. And then the shorter side is across from the smallest angle. So the shortest side is our x. Okay. All right, so I want you to let's read this together, and then I want you to pause and try and do it on your own, but first let's read it. The diagram is not drawn to scale. If it were drawn to scale, which segment would be the longest of those shown? So pause the video and think about this question. And then when you're finished completing the problem, hit play again and you can check your work. So we know that the sum of the angles is 180 degrees. So if we added all of the angles, that should equal 180 degrees. So I have 2x plus 70 equals 180. And this is an equation that we're going to balance and then solve. So I got x is 55. So if x is 55, then this is 45. Remember, it's not drawn to scale, so don't trust your eyes. So if we want to find the longest segment, it's going to be opposite this 80-degree angle. And so the longest segment is segment AB. So make sure that you know how to create an equation. Make sure you know how to justify your answer. So we can't trust our eyes. We have to have the numbers, the algebra behind this work that can help us arrive at the answer to this question. Okay, so we're going to watch a video on the triangle inequality theorem. And then we're going to come back and take some notes. So I just want you to watch the video. You don't need to write down any notes on this. But as we go through it, make sure that you're listening and make sure that you're taking in all this information. So I want to pause for a second and give you a moment to read this. So the triangle inequality theorem is defined as the sum of the lengths of any two sides of a triangle is greater than the length of the third side. And so this theorem helps determine if any three lengths can create a triangle. Sometimes we may not have lengths that are able to connect in such a way to create an enclosed triangle figure. So I'm going to pause for this one. So notice how 6 and 6 equals 12. So if in order for this to create a triangle, we would have to unhook these two pieces, and therefore it wouldn't be an enclosed figure. They would just be two lines that would be next to each other. So this would not create a triangle. Okay, so for these two examples, we're going to take some notes on these after, so just you can listen. So it says find the measures of two sides of the measures of two sides of a triangle are given. Find the range of possible measures for the third side. So we know that the small side plus the small side must be greater than the larger side in order to create a triangle. So if I add 6 and 10, that means that the third side must be less than 16. So the third side can't just be any number less than 16. So for instance, if we have 6 and 2, notice how those don't create a triangle. 6 and 4 also doesn't create a triangle. So it looks like the third side must just be slightly bigger. So it looks like the third side needs to be between the sum and the difference of the two unknown sides. So if we have two sides that are 6 and 10, then the third side must be less than 16, but greater than 4. So let's watch these next ones. So we're going to come back to the notes now, and I want us to now write the triangle inequality theorem. The sum of the smaller two lengths of a triangle must be greater than the length of the largest side. So we notice in the video it says small side plus a small side must be greater than, this is a greater than symbol, the larger side. Okay, so now going back to that other example, we want to find the possible lengths for the third side of a triangle if the given lengths are 16 and 10. So if 16 and 10 were the two smaller sides, then 16 plus 10 must be greater than the third side. So the third side must be, if I'm reading this backwards, less than 26. Okay? But what if our third side was the smaller side? So let's assume that's 16. So if 16 was the larger side, then it would be the smaller side plus the other smaller side, which I'm going to call x, must be greater than 16. So if we subtract 10 from both sides, we get x should be greater than 6. So the third side could be also greater than 6. So that's how we get that range of numbers there, right? If 16 and 10 were the two smaller sides, we have to think about, all right, what could the third side possibly be? But what if 16, the given side, was the larger side, and we were finding another smaller or shorter side? So we're going to practice more of these tomorrow. But for now, make sure you have these written in your notes and you have these practice problems here to refer back to.